Imagine having an assistant that can ace a graduate-level math exam in, like, 3 seconds. But if you ask them to find just a single verifiable academic source on Google, they fail 100% of the time.
It sounds impossible, right? But that is exactly where we are at.
Welcome to today's deep dive into the sources, where we are looking at a massive stack of technical reports, benchmark data, and expert usage tests to navigate the mid-2026 AI landscape.
That is a lot to navigate.
Yeah, our mission today for you, the listener, is to really cut through all the marketing noise and figure out exactly what you should be using ChatGPT, Claude, and Gemini for. Because, I mean, the entire AI race has fundamentally shifted.
Oh, absolutely.
We're no longer talking about those simple chatbots from a couple of years ago where you type a question into a browser and wait for a paragraph in return. We have fully entered the era of proactive, autonomous agents.
And to really ground this conversation from the jump, we need to look at what happened across the industry in early 2026. Because the major players, OpenAI, Anthropic, Google DeepMind, they all sort of woke up and realized that having dozens of fragmented legacy models was just unsustainable.
Right, it was getting way too cluttered.
Exactly. So they pruned their offerings and consolidated their architectures. And because of that consolidation, picking the right tool today is, well, it's no longer about reading a leaderboard to find the single smartest AI.
Yeah.
It is entirely about matching the specific architecture of a model to the specific workflow you are trying to execute on your desk.
So the era of the one-size-fits-all AI is effectively dead.
Pretty much, yeah.
Which means before we can even get into the mechanics of automating your daily desk work or diving into heavy academic research, we really need to understand the core 2026 identity of each of these three platforms. Okay, let's unpack this, starting with ChatGPT, specifically the GPT 5.5 family. Based on the technical reports we are looking at, OpenAI has heavily pivoted into positioning this as a versatile logic engine.
Yes, it's really the Swiss Army knife right now.
Yeah, they have the broadest features set by far advanced voice mode, computer use, a massive plugin library through Zapier, Sora video generation, Images 2.0. But underneath all of those flashy features, the data shows its core architectural strength is pure logic and mathematics.
It's unbelievable, really.
I mean, I had to read the AME 2026 math benchmark twice to make sure it wasn't a typo. GPT 5.5 Pro scored a perfect 100%.
A flawless score on a highly complex graduate-level reasoning test. It is a staggering benchmark.
Right.
And the reason it achieves that score comes down to a fundamental shift in how the model processes information. OpenAI has leaned heavily into a mechanism called deliberate reasoning.
Which is different from the old way they did it.
Completely different. In older models, the AI was essentially predicting the next most statistically likely word based on its training data. It was instant, but, prone to logic leaps.
Yeah.
But with GPT 5.5, when you give it a complex problem, it creates a structured, hidden chain of thought. It spends actual computational time verifying its own logical steps internally.
Running little mini simulations to check its work.
Exactly. It checks its work before it ever outputs a single word to you.
It's like a student working out a complex algebra problem on scratch paper.
Yeah.
Checking their formulas, erasing their mistakes, all before raising their hand to give the final answer to the class.
That is the perfect analogy. And because it has that built-in verification loop, it completely dominates in pure logic tasks where there is a definitive right or wrong answer.
Okay, so we have ChatGPT functioning as this brilliant polymath that excels at hard logic. But then we look at Anthropic's Claude, specifically the new Fable 5, Opus 4.8, and Sonnet 4.6 models.
Right.
The sources consistently position Claude as the ultimate writing partner and coder. And looking at the side-by-side text generations in the reports, Claude is significantly better at following highly nuanced instructions. It matches a specific tone without defaulting to that, generic, overly enthusiastic corporate robot voice.
Yeah, that tone matching capability is a direct result of Anthropic's training methodology, which they call constitutional AI.
Okay, explain that a bit.
So instead of just rewarding the model for completing a pattern, Anthropic trains Claude to constantly critique its own drafts against a core set of constitutional principles.
Oh, wow.
Yeah, so if you tell Claude, write this memo, but keep it highly professional, do not use bullet points, and restrict yourself to short paragraphs, its internal critique mechanism actively suppresses the urge to over-format or add fluffy adjectives.
It actually understands the constraints.
Yes, on a much deeper level than just a prompt suggestion. But where Claude's architecture really shines right now is its identity as the premier agentic coding model.
Okay, so the sources refer to it as agentic, which honestly sounds a bit like a Silicon Valley buzzword.
It does, yeah.
But looking at the GitHub benchmark data, the implication is that Claude isn't just writing a requested snippet of Python code anymore. It appears to be acting more like a digital project manager.
It absolutely is acting as a project manager, and that relies on two specific architectural features Anthropic built into Opus 4.8. First is what they call dynamic workflows, and second is the 1 million token context window.
Let's visualize that context window for a second for you guys listening, because a million tokens is just this abstract number. In practical terms, what does that allow the user to do?
Well, think of the context window as the model's active short-term memory. A million tokens means you could upload your company's entire software code base, the last 2 years of your engineering team's Slack history, and all of your product documentation.
All at once.
All at once. And the model can hold every single piece of that information in its active memory simultaneously.
That is wild.
It really is. And because it has that massive context, it can use those dynamic workflows to plan out a huge migration, deploy hundreds of parallel subagents to execute the code changes, run your test suite, catch its own compilation errors, and then merge the code.
So it is operating autonomously over a timeline of hours, not just seconds.
Right. It's writing the code, testing the code, and fixing the code before you even check back in.
Okay, so that leaves us with Gemini, Google's heavyweight models, 3.5 Flash and 3.1 Pro. The sources label Gemini as the Google ecosystem champion and a multimodal beast.
Yes, absolutely.
And if Claude's active memory is impressive, Gemini 3.1 Pro literally doubles it. It has an industry-leading 2 million token context window.
It was just massive.
So following our earlier visualization, you could feed it the entire Harry Potter series, an audio recording of a 3-hour board meeting, and an Excel spreadsheet of your yearly taxes, and it just holds it all in its head at once.
Exactly.
But the technical reports emphasize that its real differentiator is, quote, native multimodal joint reasoning.
And this is a critical architectural distinction. If we look back at the older 2024 models, when you uploaded an image and some text, the system was essentially playing a game of telephone.
Right.
It used an optical character recognition subsystem to scan the image, translated that image into text, and then fed that text to the main language brain.
It was super clunky.
Super clunky. It was a stitched together, disjointed process where context was easily lost. But Gemini was built from the ground up natively to understand all media types simultaneously.
Meaning the model itself sees the video as video and hears the audio as audio without needing a middleman to translate it into text first.
Precisely. You can put a high-resolution video clip, an audio recording, a screenshot of a user interface, and a 100-page PDF into a single prompt.
Wow.
And the architecture processes all of those inputs in the same neural space, drawing direct connections across the different media without needing separate API calls.
So Gemini is essentially functioning like a hyper-connected Google librarian who can watch a documentary, listen to a podcast, and read a data table at the exact same moment to synthesize an answer.
That's a great way to put it.
So we have ChatGPT for logic, Claude for writing and coding, and Gemini for massive multimodal synthesis. And that is great for casual, everyday use.
Right.
But friction really arises when we look at the benchmark data for academic research. I mean, GPT-4.5 has flawless internal logic for math. You would naturally assume that same logic makes it the perfect research assistant.
You would think so.
But the truth test data in the sources shows that when it comes to citing facts, that logic completely breaks down. Let's look at the 2026 tests analyzing these models for academic citations.
Yeah, this is where the theoretical capabilities of these models hit a very hard wall of reality. The researchers broke hallucinations down into two very specific categories to test the models: first-order hallucinations and second-order hallucinations.
Okay, so the first-order test is pretty straightforward, right? Does the reference the AI provided actually exist? Like, did the AI just invent a completely fake paper by a fictional author in 2024 to make its point look good?
Exactly.
But the second-order test is much more insidious. Does the reference actually support the specific claim being made by the AI? Or is it citing a real existing paper that has absolutely nothing to do with the argument?
And the results across the board are incredibly telling. ChatGPT technically won this test, but, the numbers are far from reliable.
Yeah, they're not great.
Using GPT-5 thinking with the web search function enabled, it found real existing references, passing the first-order tests over 60% of the time.
Okay.
But for second-order accuracy, meaning the claim was actually supported by the paper it linked to, It was accurate just under 50% of the time.
Wow. It's worse than a coin flip. And that was the winner.
That was the best performer. Claude was a completely mixed bag in the data. Sonnet 4, paired with a research tool, hit 100% on finding real references, but Opus 4.1 completely failed, hitting 0%.
0%.
Yeah. Overall, Claude hovered right around that same 40 to 50% mark for second-order accuracy.
Here's where it gets really interesting, though. The true shock in the data was Gemini.
Oh, absolutely.
Gemini 2.5 Pro, utilizing its deep research mode, had a 0% success rate for second-order hallucinations. Absolutely none of the real papers it cited actually supported the specific claims it was making in its output.
Zero.
It is incredibly counterintuitive. I mean, how does Google, the company whose entire legacy is built on organizing the world's information and dominating search build a model that fails so spectacularly at searching for basic facts?
What's fascinating here is that it comes down to the underlying mechanism of how large language models operate and why they are fundamentally different from search engines. We have to remember that LLMs at their core are plausibility machines. They are architecturally designed to generate text that sounds highly convincing and statistically probable, not text that is objectively true.
So they are essentially the ultimate smooth talkers. They know the rhythm of academic writing, so they just mimic it perfectly.
Yes, exactly. And the specific reason Gemini and the others fail the second-order test so badly is due to a phenomenon researchers call a double extraction failure.
Double extraction failure.
Right. So the AI goes out onto the web, finds a real highly cited paper, and brings it back to you. But the claim the AI is making wasn't actually the core finding of that paper.
Oh, I see.
The claim was just something mentioned in passing in the introduction paragraph of that paper as a summary of what some other older paper said.
Wait, I have actually experienced this exact thing.
Really?
Yeah, I was researching the effect of sleep deprivation, and I asked an AI to find sources on how caffeine impacts REM sleep. It gave me a citation. I opened the actual PDF, and the paper was entirely about melatonin.
Oh.
But in the first paragraph, the author had written, unlike caffeine, which disrupts REM sleep, melatonin does X. The AI basically just skimmed the introduction, saw the keywords caffeine and REM sleep sitting next to each other, and confidently cited the melatonin paper as proof of the caffeine claim.
That is a perfect example of a double extraction failure. It is a failure of deep contextual understanding in an academic setting. The model's attention mechanism just gets hijacked by the proximity of the words.
Yeah.
It recognizes the statistical association of the vocabulary, but it completely fails to grasp the provenance of the scientific claim. It cannot differentiate between an author stating a new finding and an author just summarizing past literature.
Okay, so if you are listening to this and you actually need to do deep research, the sources provide a very clear, actionable roadmap based on the current capabilities of each platform.
They do.
ChatGPT's deep research is incredibly fast and covers a massive amount of web ground, making it useful for broad exploratory sweeps of a topic.
Right.
Claude is best utilized for bounded research using Claude projects. That is a feature where you manually upload the specific, verified PDFs you want it to read. It stays grounded in only those documents and is trained to flag its own uncertainty.
Which is huge.
And Gemini is best deployed for massive scale synthesis and its integration with Google Scholar via Notebook LM.
But the ultimate takeaway is a really stern warning. Do not use LLMs to find your initial references.
Don't do it.
Their architectures practically guarantee they will fail you on the second-order check. Instead, you need to separate the search process from the synthesis process.
Meaning you use specialized academic search tools that are built specifically for citation mapping.
Exactly.
Tools like Elicit, SciSpace, or Consensus, you use those deterministic tools to find the actual papers. Then, once you have the verified PDFs, you upload them into Claude or ChatGPT to actually synthesize the information.
Spot on. You map the citations with deterministic software, and you synthesize the text with the plausibility machines.
Okay, so if we have to supervise these models like interns when it comes to rigorous academic research, can we at least trust them to automate our boring, everyday routine business tasks?
Well, the data suggests yes, but it entirely depends on a concept from the sources called the wrapper.
Right. Because we talk so much about the models themselves, GPT 5.5, Claude Fable, Gemini Flash, but the model is really just a brain sitting in a jar.
That analogy captures the reality perfectly. The model is just raw, isolated intelligence. The wrapper is the software environment built around that brain.
Yeah.
It contains the AI's memory management systems, its core system instructions, and its tools. The tools are essentially its arms and its eyes, allowing it to interact with the outside world.
So to put this into a practical context for the listener, a browser AI-like, when you open a Chrome tab and type a prompt into ChatGPT, is basically an assistant locked in a windowless meeting room.
Yeah.
They only have access to the files you actively slide under the door. But a desktop agent running locally on your machine is an assistant that you've basically handed a master key to your entire office.
That is the fundamental difference, yeah. When you use an AI in a browser, it has to use something called MCP, or Model Context Protocol, to reach out across the web to third-party apps like your Google Drive.
That's just messy.
It is an incredibly noisy process. Every time it pings an external app, it pulls in massive amounts of irrelevant metadata and formatting code that just clogs up the AI's limited working memory.
Oh, I see.
This metadata clutter frequently causes the AI to lose the plot and fail at complex tasks. Desktop agents, however, operate locally using command line interfaces, or CLI.
Right.
They bypass the web protocols entirely. They can write their own tools directly in your computer's terminal, natively navigate your local file system, and crucially, they maintain persistent memory across your working sessions.
Meaning, if I tell a local desktop agent how I prefer my weekly reports formatted on a Tuesday, I do not have to copy and paste those instructions again on Friday. It just remembers.
Exactly.
So looking at the workflow data, which tool is actually the best for these routine business tasks?
For the standard knowledge worker dealing with local files, Claude Cowork is the standout winner right now. Because it operates natively on your desktop, it can access your local folders securely and execute autonomous loops.
The slide deck creation workflow mentioned in the source is the perfect example of this. I mean, in the past, making a presentation meant manually copying text from a document, pasting it into PowerPoint, spending an hour messing with the formatting.
It was terrible.
Yeah. But with Claude Cowork, you point the desktop agent to a local folder containing all your old presentation slides. You give it a brief text outline of the new presentation you need to give.
And it handles the rest.
Yeah. It autonomously analyzes your past slides, parses your personal aesthetic, learns your tone and formatting preferences, and generates a brand new slide deck in your exact style, saving the file directly to your desktop.
And it executes that without any hand-holding whatsoever. Another incredible workflow from the reports involves scheduling repetitive administrative tasks.
Oh, this one is great.
You can instruct Claude to read through your team's local project documentation folder every Monday morning at 8 a.m., synthesize the key updates, and automatically post a formatted recap into your company's Slack channel.
You take a tedious hour-long chore and turn it into a 10-minute automated loop that you just set and forget.
Exactly.
Okay, that covers the local desktop environment. But what about Gemini? Because the sources emphasize its native joint reasoning, so does it have a place in automating the daily grind?
It absolutely does, but its dominance is heavily restricted by a specific caveat. Gemini is the premier choice only if your business lives entirely inside the Google Workspace ecosystem.
Ah, okay.
If your day-to-day operations exist within Gmail, Google Docs, Sheets, and Google Drive, Gemini is unmatched because it has native, seamless integration. It doesn't need to use a clunky API wrapper to read your emails and draft a reply in a Google Doc.
Okay, it's already in there.
Right. The intelligence is baked directly into the infrastructure of the platform. It avoids the metadata clutter completely.
But if your company uses a fragmented stack, say you use Microsoft Office for documents, Slack for communication, Notion for project management, and Salesforce for customer data, Gemini loses that home field advantage.
Totally.
In that scenario, the sources point back to ChatGPT, specifically utilizing Zapier MCP as the best option. Because ChatGPT has the broadest integration library, it is the most capable of automating workflows that need to jump across dozens of external, non-Google third-party apps.
And if we connect this to the bigger picture of these wrappers, there's a fascinating trend emerging in the data. As the underlying models have become more intelligent, the wrappers themselves are actually getting simpler.
Which is wild because you would naturally assume the opposite, right? That to do more complex tasks, the software around the AI would need to become more complicated.
It seems counterintuitive, yeah. But the source code for Anthropic's Claude Code recently leaked, and analysts were just shocked by the architecture. It only uses 18 primary tools to function effectively. Just 18. A year ago, developers had to build massive, highly complex software scaffolding to handhold the AI through every single step of a process, anticipating every possible error.
Right.
Now, the AI's native deliberate reasoning is so high, it doesn't need the extra scaffolding. You give it a few basic tools, its arms and eyes, and its own internal logic figures out how to use them to solve the problem dynamically.
The intelligence has migrated from the software wrapper directly into the neural network itself.
Exactly. The smarter the brain gets, the fewer tools it needs to get the job done.
Wow. We have covered a massive amount of ground today. We analyzed their core identities, tested their truthfulness in academic research, and broke down how local wrappers automate the daily grind. So, what does this all mean? What is the ultimate 2026 AI strategy based on all of this data?
The overarching consensus from every technical report and expert user we reviewed is really clear. Do not lock yourself into a single ecosystem or a single subscription. The professionals who are extracting the most value out of AI right now treat model selection as a routing problem.
You match the specific architecture to the specific task.
Precisely. You route different workflows to different models. You route to ChatGPT when you need heavy deliberate logic, advanced problem solving, and broad web tasks across third-party apps.
Right.
You route to Claude when you are writing, coding, or need reliable, persistent desktop automation through Claude Cowork. And you route to Gemini when you need to process massive amounts of data simultaneously, like a 2 million token context window, or if your entire operational workflow is housed deeply within the Google Workspace.
Yeah, you don't hire one employee to do every job in the company. You build a team of specialists.
That's the way to do it.
Which brings us to a final, somewhat provocative thought to leave you with today. We are rapidly moving from using AI as a simple conversational chatbot that answers trivia questions to deploying local desktop agents that autonomously execute our daily tasks, test our code, and build our presentations while we sleep.
Yeah, and this architectural shift raises a really profound question about the future trajectory of our own labor.
Because if the AI is the one actively practicing the work every single day, if Claude is making the slide decks and Gemini is synthesizing the data and ChatGPT is balancing the complex spreadsheets, what happens to our own professional skills?
Exactly.
If we aren't flexing those mental muscles daily, will our primary human skill inevitably shift from the act of doing the work to simply auditing the work of machines?
It's a huge question.
Are we all just destined to become middle managers for digital employees?
Yeah.
It is something to mull over as you build and experiment with your own AI stack this week. Thank you for joining us on this deep dive into the sources. We will catch you next time.